Across the darkness of space, a cosmic feast is underway. All around us, the universe is alive with motion, drama, and transformation on a scale almost impossible to imagine. Galaxies are not isolated or static. They move, collide, and consume each other in a process called galactic cannibalism. This is a fundamental force shaping the cosmos, where gravity acts as the invisible hand guiding these titanic encounters. Through this process, small galaxies are torn apart and absorbed, fueling the growth of larger ones. Over billions of years, this cosmic cannibalism has sculpted the universe, giving rise to the giant galaxies we see today. Our own Milky Way is both predator and prey in this cosmic dance. It has a long history of devouring its smaller neighbors, leaving behind ghostly streams of stars as evidence of these ancient meals. For billions of years, it has devoured smaller galaxies, leaving behind streams of stars as evidence. These stellar streams are like cosmic fingerprints, telling the story of past collisions and mergers. But the Milky Way's appetite isn't satisfied, nor is it safe. It too is destined to be consumed as it faces a dramatic future. The Andromeda Galaxy, our massive neighbor, is on a direct collision course with us. In about 4 billion years, these two giants will meet in a spectacular merger. This merger is inevitable, dictated by gravity. The immense gravitational pull between our galaxies is drawing us together across millions of light years, slowly but relentlessly. The pull between our galaxies is drawing us together across millions of light years. Over time, the two galaxies will be stretched, twisted, and ultimately fused into a new, larger galaxy. When they meet, it won't be an end, but a transformation. The collision will not destroy every star, but will instead trigger a burst of creation. Collisions like these compress gas clouds, sparking bursts of star formation. New stars will ignite, lighting up the darkness with fresh brilliance. Smaller galaxies merge to form larger, more stable ones. These violent encounters are essential for the evolution of galaxies, helping them grow and change over time. The universe is a place of violence and creation, where destruction and renewal are inseparable. Every collision is both an ending and a beginning, a cycle that repeats endlessly. Our galaxy is both a devourer and the devoured. The evidence of past mergers is written in the stars, in the faint streams and disrupted shapes we observe today. Understanding this cycle reveals our place in a dynamic, ever-changing cosmos. We are part of a universe that is constantly evolving, shaped by forces far beyond our control. The Milky Way's fate is not unique. This is how the universe builds itself. Across the cosmos, galaxies are colliding, merging, and transforming, creating new structures from the chaos. From chaos, new structures are born. The universe thrives on this cycle of destruction and creation, forging beauty from violence. The cosmic cycle of cannibalism is ongoing, shaping the universe we inhabit. Every galaxy, including our own, is part of this grand story of transformation. We are witnesses to a universe in constant motion and transformation, a place where the only constant is change itself. Galactic collisions aren't explosive, they're silent, elegant, and slow. These cosmic encounters unfold over hundreds of millions of years, so gradual that if you could watch in real time, you'd barely notice the motion. Yet beneath this calm exterior, immense forces are at work, shaping the fate of entire galaxies. Gravity, not impact, is the main force at play. It's gravity that choreographs this intricate dance, pulling galaxies together and guiding their every move. Galaxies are mostly empty space. Stars rarely collide. Even though billions of stars swirl within each galaxy, the distances between them are so vast that direct collisions are almost unheard of. Imagine two clouds of sand passing through each other. Most grains never touch. This is how galaxies interact. Their stars slip past, untouched, as the galaxies merge. When the Milky Way and Andromeda merge, their stars will glide past each other unharmed. The night sky will change, but the stars themselves will remain safe. The real drama is gravitational. Their shapes will warp, spiral arms will stretch, and tidal tails will form, painting the sky with luminous streams of stars and gas. These arcs of stars and gas are scars of the gravitational struggle. They are the visible record of the forces that have torn and reshaped the galaxies. the galaxies will twist and contort, breaking down before forming something new. Over time, their original forms will vanish, replaced by a single larger galaxy. Interstellar gas clouds, however, will collide, triggering bursts of star formation. These collisions compress the gas, sparking the birth of countless new stars. Millions of new hot stars will ignite, lighting up the chaos. These newborn stars shine brilliantly, illuminating the aftermath of the galactic encounter. The collision, though slow and silent, will be a creative event, seeding the new galaxy with fresh stars. It's a process of destruction and renewal, where old forms give way to new beginnings. This is the engine of change in the universe. Galactic mergers drive cosmic evolution, shaping the structure and future of the cosmos. Galactic mergers are among the most spectacular acts of cosmic creation, forging new galaxies and lighting up the universe with their silent gravitational dance. In about 4.5 billion years, the Milky Way will merge with Andromeda. Andromeda is racing toward us at 110 kilometers per second. The collision will be a drawn-out affair, lasting nearly 1 billion years. The first pass will shred spiral arms and create tidal tails. The galactic cores, each with a supermassive black hole, will spiral together and eventually merge. After several encounters, the two galaxies will settle into a new, larger form. The result? A giant elliptical galaxy, sometimes called Milkomeda. The familiar spiral shapes will vanish, replaced by a vast, roundish swarm of older stars. Computer simulations let astronomers predict this future in detail. Our galaxy's transformation is inevitable, a temporary structure in a constantly evolving universe. The story of Milkomeda is written in the stars. Imagine Earth's sky 4.5 billion years from now. The familiar constellations we know today will be a distant memory, replaced by a sky filled with new, awe-inspiring sights. The Milky Way's familiar band will be gone, replaced by Andromeda's warped spiral dominating the heavens. This new galaxy will stretch across the sky, a constant reminder of the cosmic dance unfolding above. As the merger unfolds, the sky will fill with tangled streams of stars, tidal tails stretching across the night. These streams will be like cosmic rivers, flowing with the light of countless stars. Brilliant new nebulae will blaze, marking regions of intense star formation. These nebulae will be the birthplaces of new stars, lighting up the sky with their radiant glow. The constellations will warp and scatter as our solar system is flung into a new orbit. The familiar patterns we once navigated by will be replaced by new, ever-changing formations. The night sky will become a swirling, unfamiliar tapestry. This chaotic beauty will be a testament to the dynamic nature of our universe. Eventually, the structured band of the Milky Way will dissolve into a dense, three-dimensional haze of stars. This dense star field will be a new kind of celestial wonder. The greatest light show in the solar system's history will unfold over millions of years. These cosmic fireworks will be a spectacle like no other, captivating all who witness it. The sky will be transformed, beautiful, chaotic, and unrecognizable. This new sky will be a canvas painted by the forces of the universe. The universe is a living, changing entity, and our view of it will never be the same. This transformation will remind us of the ever-evolving nature of the cosmos. We don't have to rely on simulations to glimpse our future. Real galactic collisions are visible in the universe. The antennae galaxies, 60 million light-years away, are a stunning example. Their long, curving tidal tails are the result of a violent merger, rich with star-forming regions. The galactic centers haven't merged yet, but the collision has triggered a massive starburst. These superstar clusters outshine anything in our Milky Way. The antennae show that mergers are both destructive and creative, forging new structures from chaos. They are a living laboratory for understanding our own galactic fate. The cosmos is filled with examples of galactic interaction. The mice galaxies, in the early stages of merging, display long tidal tails and distorted spiral arms. They preview what our sky might look like when Andromeda first passes through the Milky Way. NGC 2623, a late-stage merger, is a chaotic object with two nuclei merging at its center, surrounded by starburst activity. These systems let us piece together the life cycle of galactic mergers. By studying them, we confirm our understanding of cosmic evolution. Our galaxy's fate is a common story throughout the universe. Why do galaxies collide? The answer is gravity. The universe is lumpy. Galaxies gather in groups and clusters, bound by gravity. Our Milky Way is part of the local group, with Andromeda as its main companion. After the Big Bang, denser regions pulled in matter, forming galaxies that merged over time. This is hierarchical formation. Small things merge to make bigger things. Gravity is relentless, pulling galaxies together across vast distances. Once bound, their collision is inevitable. Galactic cannibalism is cosmic evolution in action, building complexity and structure. Without mergers, the universe would be far less interesting. What will happen to Earth during the merger? Despite the scale, the chance of our Sun colliding with another star is almost zero. Our solar system will likely remain intact, drifting into a new orbit far from the galactic center. The constellations will be scrambled, but our planetary system will survive. The real threat to life on Earth isn't the merger, but our Sun's evolution. In 4.5 billion years, the Sun will become hotter, boiling away Earth's oceans. Any descendants of humanity will need a new home long before the galaxies fully merge. The story of Milkomeda will unfold as our Sun's own life ends. Cosmic change happens on every scale, from galaxies to stars to planets. The Milky Way-Andromeda collision reminds us, the universe is never static. The sky above us is just a fleeting moment in cosmic time. Galaxies move, merge and evolve. Nothing is fixed. When Milkomeda forms, the familiar band of the Milky Way will be gone, replaced by a spherical glow of older stars. The era of spiral galaxies in our neighborhood will end. Across the universe, galaxies and clusters are merging and the cosmic web is evolving. Dark energy is accelerating the universe's expansion, making the sky emptier over time. The universe's destiny is a journey from a hot, dense beginning to a cold, dark future. Yet, it remains a place of beauty, violence, and transformation. Our ability to witness and understand this grand story is the universe's greatest wonder.